this could actually be a supercomputer. Here is how that works. Our brains are capable of extraordinary things. It is able to perform precise calculations, process language, navigate social interactions, and orchestrate fine motor skills with ease. And in doing so, the brain only uses 20 watts of power, which is roughly the same as a small USB charger. According to Boahen from Stanford University, replicating the computing power of the brain would require an enormous 10 megawatts of power. And to put it into perspective, 10 megawatts is enough to power a small town. But what if we could build a computer that is as efficient as our own brain? Well, Dr. Fred Jordan has been captivated by that question ever since he was a little kid, dreaming of building a super efficient biocomputer capable of extraordinary calculations. Together with Dr. Martin Kutter, he is the founder of FinalSpark, a Swiss-based company with the ambitious goal of building a computer inside a petri dish. Well, sort of. They are using actual neurons to build a computer that has unprecedented capabilities in terms of energy efficiency and scalability. And well, when I first heard about this technology, I didn't really think it was possible. But have a look at this. This is a different project, but scientists have already managed to have neurons play a game of Pong from inside, you guessed it, a petri dish. How does that work? Their project is based on the free energy principle, which states that all biological systems, such as neural networks, constantly strive to minimize free energy, making their behavior predictable. This leads to regular patterns of neural activity that can be decoded and understood over time. So it definitely seems possible. And the good news is, I was actually invited by FinalSpark to come over to their lab in Switzerland to see how this biocomputer is supposed to work and what it can be used for. So let's go.
So I am currently on my way to Switzerland and I'm just thinking about how to tell this story. I think before we learn about FinalSpark's biocomputer, we must first understand how our own brain works because that's what their technology is based on. So I came up with an analogy that helps me understand it better and I hope it works for you too. So check that out while I continue my journey.
Our brain has around 86 billion cells called neurons. And these neurons communicate with each other through both electrical and chemical signals.
Fuck it.
These cells determine all our actions and everything we experience. Now, think of our brain as a sophisticated postal network. Incoming letters represent external stimuli like light hitting your eyes or sound coming into your ears. The letters are sorted quickly, with urgent messages sent off to specific parts in the body or brain, such as a sudden loud noise. At each destination, postal workers deliver messages to residents. These can be thought of as signals reaching neurons, triggering actions or thoughts. Just as you might write a response when you receive a letter, neurons too can send messages throughout the whole body, ensuring a continuous flow of information. So I have arrived in Switzerland and it's absolutely beautiful here. And after a good night's sleep, it's finally time to go to the lab and learn all about this biocomputer. I have many questions, like how do you create these cells? How do you communicate with them? And perhaps most importantly, why should we want this? I was welcomed by co-founder Fred Jordan, who was keen to help me answer all these questions.
I'm good, how are you?
But first things first, let's meet the team.
Hello.
Hi, Julius. And after that intelligent moment, it was time to answer the first question. how do you create these cells? How do you start the process from creating the cells, the stem cells from scratch? Do you create those, or
No.
can you buy those? Or
You can buy them. You can buy actually neuroprogenitors. So neuroprogenitors are derived from induced pluripotent stem cells, which are derived from cells from the skin.
Okay.
So if you buy neuroprogenitors, actually you are buying cells which are going to become either glial cells or neural cells.
Okay.
Nothing else.
Stem cells are basically blank slates that we can program into becoming anything. And in this case, well, it's brain cells. Alright, so we buy stem cells, we program them into becoming brain cells, but how do you communicate with these cells? Well, FinalSpark uses so-called neurospheres. These are artificially created 3D structures with living neuron cells in them that are placed inside a medium. And from inside this medium, the cells can be stimulated through both electrical and chemical signals such as dopamine. Let's say we want to give it a complicated task, such as the simulation of weather patterns, or an easy task like subscribing to this YouTube channel. Through a regular computer, the task is then translated into a series of specific electrical and chemical stimulations. The neurons are prompted to tackle the assignment and figures it out just like our own brain would. Once they figure it out, their activity is measured and is sent back to the computer. This data is then translated by the lab's AI system into something that we can understand again. Rather than using the free energy principle, this system adopts a dopamine-like reward mechanism similar to that in the human brain. The neural network is trained with rewards and punishments. It receives dopamine-like positive stimulation when successfully completing tasks. This reward-based feedback guides the network towards more efficient and accurate responses. While I was over at the lab, they were actually installing a new badge. And I actually got to communicate with this newly created biocomputer.
Maybe I'll let you once do a stimulation yourself.
Okay.
Press on the button 1.
So if I press the 1 on the screen, I will send this signal to the cells, and that will result in a spike.
Yeah.
This is the activity you see. So I don't want to harass it too much, but I am currently talking with a bunch of cells.
That's it.
Currently, it's not possible to perform extreme calculations as they're still figuring out the best way to communicate with these cells. However, they're working together with a few interesting universities to figure this out. And the universities can actually communicate with these cells through the cloud, which is a great indicator of one of the potential use cases. And speaking of use cases, it is time to answer the most crucial question: why should we want this? Well, the first reason is actually energy efficiency. Remember that our brain only uses 20 watts of power? That is a huge difference compared to a regular computer. I know it's still early days and it's hard to put an estimate on it, but how much more efficient would you say that it is?
Compared to artificial neural networks, if you talk about inference, it's like 1 million times more efficient.
Okay.
If you talk about learning, maybe 1 billion times more efficient.
Wow.
So, in a world where people are fighting just to get 10% of energy efficiency more, we are talking about numbers which are incredible.
If they can make that happen, those are indeed incredible numbers. But that's not all. The cells actually replicate themselves, which results in automated and basically zero-cost scalability.
And now with neurons, it's easy. You just scale up. You have 1, you have 1,000, you have 1,000,000. It's thing. And at the end, you can recycle them. It's simple. It's done automatically. If you want to create many chips or big chips, you have to have silicon, and you have to get the silicon. It's really complicated to scale up IT in silicon-based.
Well, great. Anything else?
It could be that sometime in the future, you can copy your brain into a neurosphere. Continue to live there. Like a backup of your brain. It's a science fiction, but biological twin, which tells you what to do in your life.
I don't know about a biological twin, but a backup would be nice. So does that mean that in the future all our laptops and iPhones will have tiny petri dishes in them? Probably not, as one bacterium could ruin the entire computer. But think of the insane energy demands that is necessary for cloud computing and AI. As technology advances, so does their demand for power. For example, chipmaker Nvidia is expected to ship 1.5 million AI server units by 2027 each year. Those will probably use as much energy as some small nations do. And that's where companies like FinalSpark come into play. It is probably going to be a while until we see the first practical use of a biocomputer. But given the rising demand for computing power, it is bound to be a recurring topic. In the meantime, you can actually try out this demo on their website. The cells recognize the target and steer the butterfly towards its goal. Pretty insane. Please let me know what you think about this technology in the comments. Also, leave a like and subscribe if you enjoyed the video. That will help get the video out there to more people, which will help me to keep making stuff like this in the future. So, see you in the next one.